Okay, so today we're going to talk about section 7.1, and 7.1, as you can see, is integer exponents. We've already kind of talked about exponents way back in chapter 1, if you can remember that far back. But today we're going to simply just evaluate and simplify an expression that contains either a zero or a negative exponent. And we're going to see what those mean and see how those really work together. So the first thing that we need to do is we need to remember what an exponent is. So if we look at these two examples, remember that this here is our base, and this up here is known as our exponent. So in this second example here, this is also our base, and this is also our exponent. Now if we remember what these exponents and what these powers really mean, is that this one, the first example, really tells us that this is x times by itself 5 different times. And then this one over here, this is 3 multiplied by itself a total of 4 times. And we can evaluate this if we can. So this one here we can just rewrite as x to the 5th, because obviously we don't know what x is, and there's no reason that we should know. This one over here, we can say 3 times 3, that's 9, times another 9, which is 81. Or we could just punch that into our calculator and still get 81. Now, an exponent is an exponent is an exponent. And so if we take a look at these more advanced examples, we can see that the same rules apply no matter what the base is. In this case, what we're dealing with is we're dealing with bases that end up being fractions. Now, we've talked about fractions a lot and how fractions really work. Now, if we use the same rules that we did in the last slide, we can say that 2/3 to the power of 3 is the same thing as saying 2/3 times 2/3 times 2/3. And if we remember anything about multiplying fractions, we know that we can multiply these straight across. And so what this is end up going to be is this is going to be 2 times 2 times 2, which is 8, and 3 times 3, which is 9, times another 3, which is 27. And so 2 to the 2/3 to the third power ends up being 8 over 27. Now if we continue this and we look at an example that doesn't have any numbers, we really still do the same thing. And so what we can say is that this is going to be the fraction or the base multiplied by itself, and we're looking at an exponent here of 2, so it's going to be multiplied twice. So we say x over y times x over y. And if we look about simplifying this and we multiply our fractions straight across again, you'll see what we get is we get x times x, which you know now really means x times x over y times y. And if we look back at what we know about exponents, we can say that this is x to the second power over y to the second power. Now, what's interesting about this is that now what we can do is that we can kind of come up with a rule. And so what we can say about any time that you have a fraction is what we need to do is we need to take this exponent here and give it to each piece of the fraction. Because if you look at the answer over here, we ended up with x to the second power, y to the second power. And if we look at our fraction just ended up being x over y. But now that we had the power of 2, look what happened. In a way, it kind of got distributed. So what we can say is this example over here, 2/3 to the third power, what we really did is we took this 3 and distributed it here and distributed it here, and what we came up with is now 2 to the third power over 3 to the third power. And over here, x over y to the second power, we took this 2 and kind of distributed it, and we ended up with x to the second power over y to the second power. So anytime you see an exponent outside, you can give it to each piece that's inside the parentheses, whether you're having a fraction or whether you're multiplying, anything like that. And we'll talk a little bit more about that later. But what we want to look at is anytime you have a fraction like this, each piece gets that power. And so now what we can talk about is we can talk about some rules with exponents. And so our first rule has to deal with zero exponents. Now with zero exponents, the rule here is to simply do the following. So anytime we encounter a zero exponent, what we can do here is we can say any number and we're going to say except 0 to the power of 0 is always 1. So let's take a look at some examples here. So if we have a couple examples and I say 4 to the 0 power, it equals 1. And let's say I take 3 to the 0 power, that's 1. What if I take 4,321 to the 0 power? Well, you guessed it, it's going to be 1. Now, we could also say something about negative numbers. So if I take negative 3 in parentheses to the 0 power, this is also 1. Now the last one, and now we talked about this before, if I use the example negative 3 to the 0 power, your immediate thought is that this is going to be 1. Well, in fact, this is not 1. Because remember I told you to think of these things as negative 1 times 3 to the 0 power. And if we look at our order of operations always tells us to do exponents first. And so if we say, what is 3 to the 0 power? Now you can say, well, this is 1. So we have negative 1 times 1, which is now actually negative 1. So we really need to be careful in situations like this, where we have negative 3 on the outside without any parentheses. See how these two things are not the same? This thing right here means that these are not equal. But we can see that these things are not the same. And we've talked about examples like this before when we were discussing normal exponents. We need to be careful of where the parentheses are and where our negatives are. So whenever we see parentheses, we make sure that, okay, well that's always 1. And then here, if there's no parentheses, we should assume that this is being times by a negative 1. So why don't you go ahead and take a second. You can pause the video and go ahead and try these on your own. Take a few minutes to do these. These shouldn't go too fast. And then as you do that, I'm going to work through the answers here. Please don't try to check the answers before you finish them. Go ahead and finish them first. I'm going to go ahead and work these problems. So 3 to the 0 power, well, we know now that that's just 1. Negative 16 to the 0 power. Again, this negative 16 is in the parentheses, so this is equal to 1. Now any number to the power of 0 is always 1, so despite this being a large, gigantic number, this is always equal to 1. Same thing goes with this example up here. Fractions, doesn't matter, equal to 1. Now this last example, we need to look at and be aware of where our negative is. Now if we rewrite this problem, this is really negative 1 times 5 to the 0 power. Evaluate our exponents first. We get negative 1 times 1, which in this case is negative 1. So go ahead and check your answers and see how you did. And if you're struggling, you can do the guided practice. in your book, and obviously the odd ones will show you the answers, and you can check those and reference those as well as any of the examples in the book. Now we're going to move on to the next rule of some of our exponents, and this is going to be a little bit more complicated than anything to the 0 power is always 1. And we're going to talk about negative exponents. And whenever we think about negative exponents, I'll show you how these things look. So if you have a negative exponent, it's going to look something like this. So you're going to have some number to the power of, let's say, negative 1. So in a way, this is writing and reading this. This is 2 to the power of negative 1. And this is how we want to read these. We don't want to read these any other way. This is 2 to the power of negative 1, not 2 to the minus 1. I mean, you can read it that way, but we want to say 2 to the power of negative 1. And what I want you to think about, whenever you see a negative exponent, not just a negative, but a negative exponent, I want you to think about reciprocal. Remember reciprocal. We're not talking about opposite reciprocal, just plain old reciprocal. Remember, reciprocal just means to flip. So if we have anything and we're talking about reciprocals, and I asked you, okay, what was the reciprocal of A? Remember, you would tell me 1 over A. The reciprocal of 2, you would tell me, is 1 over 2. The reciprocal of, let's say, 3 over 2. If we just flip these, then we get 2 over 3. And then let's say we have the reciprocal x over y. The reciprocal of that is y over x. So whenever you see negative exponent, I want you to think in your mind reciprocal or flip, whatever we're talking about, whatever this. And what we're going to do with a negative exponent is we're going to flip the base. Now remember, the base, if we look at our example up here, which is 2 to the negative 1, our base is the 2. This up here, this is our exponent. We don't want to worry about that. We're just simply worried about our base. So we're always going to flip the base. And we're going to see some examples of these here really quick. So if we look at some of these examples, remember, we want to think about this, and we're going to think about negative exponents. We want to think reciprocal. That means we're going to flip the base, but then what we want to do is we want to then keep positive exponent. So what's going to happen here is taking that reciprocal gets rid of the negative, but we still have to keep our exponent. So let's take a look at what's going to happen here. So if we have 3 to the negative first power, what that means is take the reciprocal, and abbreviate that recip. And so what that is we're going to have 1/3. And then if we keep our positive exponent, the positive exponent of that is 1. And if we think about this, 1/3 to the power of 1, we know from our old exponent rules that anything to the power of 1 is simply itself. So we have 1/3. So in a way, if we look at this, anytime we see something, any number that has the power of negative 1, basically means that we're taking the reciprocal of it. Because if I have 3 and I tell you to take that to the negative 1 power, all you're really doing is making a reciprocal. So let's look at our next example then. So we have 2 to the negative 2 power. The negative means we take the reciprocal, and we're taking the reciprocal of what? Well, we're taking the reciprocal of the base. And so our reciprocal here is then 1 over 2, and we're keeping our exponent. So we're going to put this in parentheses, and we're going to say to the power of positive 2. So we see how we go from here to here. We take the reciprocal of the base, and then keep the positive exponent. Now remember back a couple slides when we were talking about this, we can in a way distribute this 2 to each piece, and so what we end up with is 1 to the second power over 2 to the second power. And we know what 1 to the second power is. Well, that's just 1. And 2 to the second power, 2 times 2. And I can show you this. This is 1 times 1, which is really just 1 over 4. So 2 to the negative 2 power, or the power of negative 2, ends up being 1 over 4. Now let's take a look at our last example here. Our last example shows us 4 to the power of negative 2. Well, the negative, taking the reciprocal, so what's the reciprocal of the base, which is 4, ends up being 1 over 4. What do we do with this exponent? We keep the positive exponent. So this is all to the power of 2. We do the same thing, and we can kind of take a shortcut here, and we can ask ourselves, well, what's 1 to the second power? What's 4 to the second power? Well, 1 to the second power is just 1, and 4 to the second power, hopefully you should know that that's 16. And there's our answer. And that's all we do. So in order to find negative exponents, what we're doing is we're taking the reciprocal of whatever the base is, so the reciprocal of the base, so whatever the base is in each situation, so the reciprocal of 3, 1/3, reciprocal of 2, 1/2, reciprocal of 4, 1/4, and then keeping whatever the positive exponent is. So once we take the reciprocal, it kind of gets rid of the negative. So each time here, what did we do? We took the reciprocal, it got rid of the negative. Took the reciprocal, got rid of the negative. Took the reciprocal here, got rid of the negative. And we can keep doing that and apply these to different ways. So if I gave you other examples, hopefully that you should be able to do is take the reciprocal of the base and then keep the positive exponent. Okay, so let's look at a couple more examples. Now we're looking at examples that aren't so cut and dry. They're not as straightforward. Now remember I told you if we think about the negative 1 by itself simply means reciprocal. So what's the reciprocal of 2/3? Well, you should tell me that this is 3 over 2 to the power of 1. Well, we know anything to the power of 1 is itself. So we get 3 over 2. Alright, let's move on to our next example. Now, with a fraction, we talked about this before, is what we have here is we have a fraction. When we take the reciprocal of this, because how do we know we take the reciprocal? Well, we have a negative exponent, so we're going to take the reciprocal here. And so what's the reciprocal of 1/2? Well, we can say we're just flipping the numerator and the denominator. We get 2 over 1, and we keep our positive exponent again, which is 3. Now, what we can do here is we can do what we did before and distribute that 3 in a way, the power of 3, to each one of these pieces, but there's also an easier way, especially when we have this over 1. We can simplify this to simply just, well, what's 2 over 1? Well, you can tell me that's just 2 to the power of 3. Makes things a little bit easier. So we can say 2 times 2 times 2, which 2 times 2 is 4, times another 2, well, that just simply equals 8. So anytime we see something like this that you have a denominator of 1, that we can simplify to just simply being the whole number, or you could go the long way and you could say, well, this is 2 to the 3rd power, 1 to the 3rd power, and you'll still get to the same answer. Now finally, we have an example that doesn't have any numbers in it other than our exponent. So we have x to the power of negative 2. Well, if we think back at our last examples, what is the reciprocal of x? Now we know we need to take the reciprocal because we have a negative exponent. So the reciprocal of x, so let's think about the reciprocal of x. Well, if this is x over 1, because we can always put something over 1, our reciprocal then is 1 over x. And we've talked about examples like that. And we always keep our exponent, but it's positive now. So we have 1 over x to the power of 2. Now if we follow our same procedure, and we say, okay, well, we can kind of distribute this power to each piece, and so what we end up with is 1 to the second power over x to the second power. Well, there's some things that we know and some things that we don't know. First of all, ask yourself the question, do I know what 1 to the second power is? Well, yeah. That's just 1, because it's 1 times 1. Do I know what x to the second power is, though? Well, no, because I don't know what x is yet, and so I can just simply leave it x to the second power. So really all I'm doing is the same thing, it's just now I don't really know my numbers. And so if I don't know a number, I can just leave it as the variable with whatever the exponent is. Now, finally, there's another way that we can look at negative exponents. But let's look at these two problems, and let's look at them kind of in a way of being by themselves. And let's try to do these problems first. So if we look at this, the way that we normally did negative exponents in our first example is whenever we saw the negative, what did we do? We took the reciprocal. So if we take the reciprocal of this, what we end up getting is we get 3 over 2 to the power of positive 2. Because once we take the reciprocal, then it becomes positive. And then what we can end up doing is this is the same thing as saying, well, we're going to distribute this power of 2. Now we're not multiplying it, we're distributing the power. So 3 to the second power over 2 to the second power. And this simply becomes 9 over 4. Okay, well that seems pretty easy so far. But let's look at the example where we don't have our numbers. Now this isn't so easy because now we have things that are working a little bit different. So what we can do is whenever we see a negative exponent, what we can do is we can change places. So if we have a negative exponent in the numerator, or we have a negative exponent in the denominator, what we can think of this as doing is in a way switching places. So if we have one in the numerator, what we can do is it'll send it to the denominator. And if we have a negative exponent in the denominator, it sends it to the numerator. So let's look at this example down here. So if we use this kind of little rule, is that we send it to the numerator or we send it to the denominator. In this first case, what we have is we have x to the power of negative 3. Now if the rule is if it's in the numerator, then we send it to the denominator. And so we can move from numerator to denominator, or what we can do is we can move from the denominator to the numerator. So basically, whenever we see a negative, it's kind of in a way thinking about our opposites. And if we think about that, well, we know that a negative exponent means reciprocal, so we're just switching the position. And so in this case, what we're doing is we're just switching the position. And so if I have x to the negative 3 power, what I can do is I can move that from the numerator to the denominator, and whenever I move it, let's make a little side note here. Whenever you move, the exponent becomes positive. If we look at this first example up here, whenever we took the reciprocal or whenever we changed it, What happened to the exponent? Well, the exponent became positive. So the same thing will happen. So this x to the negative third power, what that's really going to do is it's going to come down to the denominator, and it's going to become positive. And then what we can do is then we can look at this y to the negative 2 power, and this is going to come up to the numerator because of the negative exponent. So really what's happening here is these two things are going to switch positions, and so this is going to become y to the second power over x to the third power. So we moved from the numerator with the negative third power, moved it down to the denominator, and here it is. And then what we can also do is then with this y to the negative 2 power, well, that's going to move from the denominator up to the numerator, and then here that one is. Okay, so we're just changing its location. So if it's in the denominator and it's negative, you move it up. And if it's in the numerator, if it's on top and it's got negative, we move it to the bottom. Look at our first example. If I was to look at this and say 2 to the negative 2 power, what happened? It moved to the bottom and it became positive. Same thing here. I have to distribute that to each piece, so it's 3 to the negative 2 power. What's going to happen there? Well, it moved to the top. So if we rewrite this example, 2 over 3 to the negative 2, remember what I said, is we can kind of distribute this power to each piece. And so what does this become? This becomes 2 to the negative 2 power over 3 to the negative 2 power. Well, if we just move this down, move this up, they're switching places, and they become 3 to the 2 power and 2 to the power of 2, which, coincidentally, is exactly what we have right here. So whenever it's negative, you can either move it up or move it down, depending on where it started. Now the tricky part comes when we try to simplify these expressions. When we talk about simplifying expressions, before what we did is we either added like terms or anything like that. But now when we're talking about exponents, to simplify expressions, we can't have any negative or zero exponents. So we want to try to get rid of as much as that we can. And what I want you to understand here is that I want you to understand that when we have multiplication, we can treat each piece separately. And so each term, we have each term here. So if we look at this first example, 2x to the negative 2 power, y to the third power. What this really means is that this is 2 times x to the negative 2 power times y to the third power. And so what we can do is we can treat each piece independently. First thing is we look at this 2. Is there any exponents with this 2? No. We can move on. The x, is there any power? Yeah. Well, let's ask ourselves, well, we can't have negative or zero exponents. Is this a negative or a zero exponent? Well, yeah. So how can I change x to the negative 2 power? How do I do that? Well, if we look at our examples, 1, we see negative, we think reciprocal. So what's the reciprocal of x? Well, our reciprocal of x is 1 over x to the power of 2. Remember, it goes positive. And then so that's times 2 times y to the third. Now I have to remember, okay, well, this isn't working out very well. This is a lot of work. Well, if I look at my last idea, and I said either moving it up or moving it down. So let's do it that way. So let's make this, and we're going to look at this again, and we're going to say, okay, well, let's just rewrite this. Well, now that we know that these are all separated by multiplication, we can look at it this way. Okay? Do I have a clearly defined numerator or denominator? Well, no, this isn't a fraction, right? Well, how do we make this a fraction? How do we make any whole number a fraction? Well, we just put it over 1. When we put this over 1, okay, now we have 2 times x to the negative 2 power times y to the 3rd power. Well, that's not really doing anything for me. I need to get rid of that negative 2 power. So if I look at and I think about, okay, well, the negative means I either move it up or move it down. So we have x to the negative 2 power. Okay? If it's in the numerator, where does it go? Well, we can just send it to the denominator. And so now what we have is we have a new problem that says 2 times, well, we still have 2, and we still have y to the 3rd power. Now this is divided by, well, what's going to happen is it's going to be x to the power of 2, because remember, when I move it, I get rid of my negative. The power still stays the same. It just, instead of being negative, it becomes positive. I'm basically taking it to where it needs to be. So it's saying that it's in the wrong spot. Well, it just needs to send it from the numerator to the denominator. So this is my answer. So when we simplify an expression, this goes back to meaning that we don't always know what x and we don't always know what y is going to be, but we can get ready for when we do know. And so in this case, we don't know what x and y is, so we can just leave them how they are. And so in this case, all we really had to do is we looked, okay, well, the x is the one that had the negative power. Let me rewrite this one here. X has the negative power, so that one moved down. And when it moves down, it gets rid of the negative, but the power stays the same. So let's look at a little bit more difficult example. So let's look at this example right here. Okay. Now we have a lot of things going on. Now let's look for things that we can change. So immediately what we need to look for is a to the 0 power. What is a to the 0 power? What is anything to the 0 power? Well, it's just 1, right? And so let's rewrite this problem getting rid of that. So now what we've done is we've kind of got rid of some of the things that we don't know. Or not the things that we don't know, but the things that we know that we don't necessarily need to keep worrying about. Because we know whatever a is, as long as it's not 0, as long as it's any number to the 0 power, is always going to be 1. And so we can say this is really 1 times b to the negative 2 power over c to the negative 3 power. That needs to get rewritten. C to the negative 3 power times d to the 6 power. Now, we don't really need that 1 there. That's just kind of extra. So we can kind of get rid of that 1. Now we need to look at this and say, well, is this simplified? Well, no, it's not simplified, because we know in order to be simplified, we can't have negative or 0 exponents. And do we still have negative exponents? Well, yeah. And if we use our rule, either moving from numerator to the denominator or from the denominator to the numerator, what we can say is we can say that this b is going to move down, and then what else is going to move? Well, the c to the negative 3 is going to move up. Because it's negative, it's where it's not supposed to be. It needs to go to where it's happy. And so by going from the bottom to the top, it's going to make it happy. And with the b, going down to the bottom is going to make it happy. And so what we can come up with is, now that c is on the top, what happens when we move it? Do we keep the negative? Well, no. It becomes positive. And then when we move this, we have b to the 2nd power times d to the 6th power. And that's really all that we have to do. So when we look at these things, we need to ask ourselves, okay, is there any negative exponents? Okay, if there's a negative exponent, I just move it to the other spot. So if it's in the numerator, it goes down to the denominator. If it's in the denominator, it goes up to the numerator. And so finally what I want you to do is I want you to take a second, you can pause the video, and try some of these on your own. If we don't have a fraction and we need to move something, make a fraction. And how do I make a fraction? Well, just put it over 1. So as you take and try some of these, what I'm going to do is I'm going to take the next couple seconds and I'm going to do these. I'm going to talk you through them. Okay, so we have negative exponents, we need to get rid of those. So we need to put this over 1. Does the 2 have an exponent? Well, no, so that can stay there. And so what we have is we have a to the first power, or a to the negative 1 power. So what I can do is I can move that down, and b to the negative third, I can move that down. Now remember, this is all multiplication, so it stays multiplication. And so what we end up with here is we end up with 2 is left on the top. So we have 2 on the top, and now we have a to the first power times b to the third power. Okay, let's look at the next one. 2 times r to the 0 power times m to the negative 3. Put it over 1. Well, the r to the 0 power, well, we know that just equals 1. This piece right here is going to move down. So we get 2 times 1 divided by, well, since the m moved down, we have m to the power of positive 3 now. And so we have 2 over m to the third power, because we know that this times 1 doesn't really mean anything. Now let's look at this one here. Okay, we already have a fraction. We have a negative exponent, and well, what do? We send it to the bottom. So whenever I move something, what happens? Do I get 0 over 7 times r to the third power? Well, no. What I end up getting is on the top, on the numerator here, whenever we're left with something, we're always left with a 1. Because remember, this is 1 times r to the negative 3 power. Well, if I get rid of the r, what am I really doing? Well, I'm just taking away that r, and I'm still left with the 1 on top. I always have 1 on top. Since we're talking about multiplication, we can't ever have 0. You can't ever multiply something other than by 0 to get 0. So if we're ever doing anything, we're always getting rid of 1. Think about those times where we took 2 divided by 2. Well, that didn't equal 0. 2 divided by 2 is always 1. Okay, well, that's going to be it. So if you check back on the Moodle page, you will find where your homework is at.